right, let me go to the top. All right, so calculate the following. Express answers with correct number of significant digits. Now this is a key here. Show your work. Even if you're doing density, I want to see the formula you used. If you're doing a conversion, I want to see the chart or something related to the chart so that I can see that you know what you're talking about. Now this is just a metrics conversion, so showing your work could be as simple as showing that so that you know the prefixes. We're going from decimeters to hectometers, so 1, 2, 3 spaces to the left, 1, 2, so the correct answer is 3 spaces to the left. 2 digits, significant digits, 2 significant digits, so that's the right answer. Another way you could solve this, remember I said know what those mean, and then you can go to the base unit. So there are 10 decimeters in a meter, and then from the base unit to the one you're looking for. So you could have that set up as well. So this would be good enough for your work, this would be good for your work, but you got to show me something. Don't just have that as your answer, which some of you did on your quiz. Because if you mess it up, I'm just going to take all the points off, because I can't see what you did. So show me that you have done your work. All right, now this one looks kind of scary. We've already answered one like this. A maximum allowable concentration is 25 grams per centimeter cubed. Sometimes I think it helps to write down what you got. All right, I have grams per centimeters cubed. Over an 8-hour period. At this level, what mass of carbon monoxide in milligrams is present in a room measuring? So we've done that several times now where we have to find the volume, length, times width, times height. Notice it's meters, meters, and meters. So when I multiply those 3 together, I'm going to get meters cubed. So I could look at it as a volume, 21.5 meters times 16 meters times 32 meters. I get 21.5 times 16 times 32. And I get 11,008 meters cubed. Now I could round the significant digits there. Since that has 5, I really should only have 2. I'm going to wait till the end to round. Remember, when I can avoid it, I only want to round once, not twice. All right, now I'll give you a hint here. Think density. Now the reason you can think density is you have grams, which is mass, and you have meters cubed, which is volume. So grams per meter cubed. Or you could look at it as this. There's what I have, and I want to plug this number in so that meters cubed cancels, and I end up with grams. So I can do 25 grams per meter cubed. Meters cubed will cancel, and so I end up with my unit in grams, which is a mass, and I'm looking for mass. What mass of carbon monoxide? So I have 11,008 times 25, and so I get that. Now, how many significant digits? Well, looking back at the problem, I got 2, 2, 3, and 2. So I only want 2. So I'm going to say 2.8 times 10, 1, 2, 3, 4 to the 5th grams. And if you had that, you'd almost be right. Why almost? Well, because I asked for milligrams. So we still have to do 1 gram, 1,000 milligrams. Multiply that and you get 2.8 times 10 to the 8th milligrams. That's the right answer. So there's one way you can solve it. Now I have a hint, think density. So according to our triangle for density, remember mass has to go on the top or you're going to do it wrong. We're looking for the mass. You hold your hand over the mass, and it is density times volume. So M equals D times V. Now there's D, there's V, so D times V. So that's essentially what I did. All right, next question. The density of aluminum is 2.70, so I give you the density again. So once again, that same triangle. Remember, mass has to go on the top. We're looking for mass. Mass equals, hold your hand over the mass. It's D times V. So 2.7 grams per centimeter cubed times the volume, 15.6 centimeters cubed. Notice the volumes are the same, so they cancel. And my unit will be in grams, and I get 2.7 times 15.6. So my correct answer is 42.1 grams, 3 digits in my answer because each of those had 3, so 3. 2.70, final 0 after the decimal. Next one, zettameters. I'm not making that up. That is a prefix. You could abbreviate it ZM if you'd like. All right, so I have 1 zettameter equals 1 pen is acting up here. See, it's lagging behind a little bit. Let me slow down for a second. All right, so 1 zettameter is 1 times 10 to the 21st meters. Now notice here again I have centimeters and I have meters, so I have to come up with the conversion to connect them. Same one on our quiz. Meters cancel, zettameters cancels. I'm at centimeters, 2.54 centimeters in 1 inch. Centimeters cancels. And there we go. So there's our setup. So now to plug this in our calculator, we multiply across the top, and we're going to just divide by 2.54. Make sure we're putting it in our calculator properly. 48.00 times 1 times 10 to the 21st. Like I said today in class, know how to use your calculator. Times 100 equals, I got to sit on that side, right? Now divided by 2.54, so there's the correct answer. 4 digits, because our original number had 4 digits, so 1.8897. We got to round at the 4th one, so 1, 2, 3, 4, so that becomes 1.890 times 10 to the 24th inches. Know how to use your calculator. A bucket has a capacity, centimeters cubed, we're looking for liters, 655.3 centimeters cubed. This is the conversion you have to know. So that's going to give me 0.6553 liters. That divided by 1,000. 4 digits, 4 digits. Don't drop any of those numbers. All right, last couple. Michael Johnson won the 200-meter race in 19.33 seconds. We want it in miles per hour. 2 ways we can do this one. 200.0 meters on top. Why on top? Well, because the meters are going to become miles. Seconds, 19.33 seconds on the bottom, because seconds are going to become hours. So miles per hour is what we're going to end up with once we change this to miles and seconds to hours. Well, a separate way we could do this is convert the 200 meters to miles and get that answer. Change 19.33 seconds to hours, 60 seconds in a minute, 60 minutes in 1 hour, and get the hours, miles, and then take the miles and divide it by the hours, and you will get miles per hour. I like to do it in one chart. That way I only have to calculate once. So I've changed meters to miles with the conversion that was given. 60 seconds in a minute, 60 minutes in 1 hour. So why did I put seconds on the top? Well, because it was on the bottom. So seconds and seconds cancel, minutes and minutes. I have hours on the bottom, miles on the top, so I know I did it right. 200 times 60 times 60 divided by 19.33 divided by 1,609. And as we already answered this one, you see the significant digits, 4 and 4, so 23.15 miles per hour, or miles over hours. All right, what would a speed limit sign in Canada look like? Notice what the question is. Some of you got that wrong on your bonus on the quiz that you tried it, because I asked, what would the title of the book be? A little bit more original. So now I want to know what the speed limit sign looks like. So I have miles per hour. Remember, per hour. Again, there's a video on that. Look it up. I gave you the conversion from miles to meters in the previous problem. 1 mile, 1,609 meters. 1,000 meters in 1 kilometer. So I have kilometers on the top now. Meters cancels, miles cancels. I have kilometers per hour. I want kilometers per hour. So that's it. 70 times 1,609 divided by 1,000. And I get that. Now 3 digits, so 112.6 becomes 113 kilometers per hour. So what would the sign look like? Well, it might look something like that. Okay. And our last one, we're measuring everything we know for sure plus 1 more. Oh, 2 more, sorry. 56, between 56 and 57, so maybe 56.8 is where we're rounding. The one we don't know, 6.3 and 4, so 6.32 maybe. And then the last one If you perform an experiment and find the density, the correct density is 4.25. So 4.25, what's your correct one, minus what you got, divided by the correct one. Remember, absolute value times 100. This 100 does not count for significant digits because it's exact. It's part of the formula. Infinite number of significant digits. But we have two different rules. We're subtracting and then we're dividing and multiplying. So when we subtract, we go by decimal places. Then we take the absolute value. So negative 0.50 becomes 0.50, 2 decimal places, because of the 2 decimal places in both of those, divided by 4.25, and then times 100. So 0.5 divided by 4.25 times 100. And I got 11.764705888. No matter how many times I say it, people are still going to give me that answer on their quiz, or on your test, and I got it on the quiz. You should fix any number you get from your calculator. 2 digits, 3 digits, infinite digits. So that I should have 2 digits because I'm dividing and multiplying. And there it is. So be prepared. Watch it 25 times if you have to. Good luck.